Okay, so I'm talking about question 3b. Sorry, I'm just starting everything over because I'm not going to use any of the old stuff. So where we want to know the property of DFAs essentially that makes it accept a prefix-free regular language, right? That's basically the question. And so your initial hypothesis was only final states are accessible from the start state would be a property. Which this is an example of, right? This still has a problem though, right? So if we have 1, where should I put it? I'll put it over here. So 1 is accepted, right? But 1 is also accepted.
Right.
And so this is still an issue, even in the correct formulation of the problem, right?
Right.
Because if I cross off this 1, then I get to an accepted string.
Right.
And that's the whole point of being prefix-free.
Right.
Going back to what we were talking about earlier too, what's the problem here? The problem's almost the same problem as what we were talking about before, but in reverse, right? Like, how did you get from here to here? It was this transition, right?
Right. Right.
Which is from a final state to a final state.
Right.
So basically, like, one way, like, I guess I want to think about this prefix is, like, oh, it's this we're removing.
Yes, I think so.
Yeah, this is
taking
what
off
we're
something
removing.
from the end. Yeah.
This is the prefix. So I have this backwards, is that right?
I think you have it the correct way, but what we're doing with it is we're leaving the
So
prefix.
this is the accepted string. Now, the whole thing is the accepted string.
Yeah.
This is the prefix, right? You remove the...
I think you just don't want to be able to have the sigma on the left
I'm just gonna
be
read.
accepted. Yeah, you're good.
Right, which makes the tau, I want to pause it. Right, so tau is the prefix, because it's non-empty and it's what we're removing to say it's no longer accepted, so.
Right, okay.
Does that make sense?
Yeah.
So you should think of this as the prefix.
Okay.
Okay, and we remove that, and this is no longer accepted.
Right.
You can think of removing the prefix as kind of like rewinding time
Okay.
to a certain degree. Right, and so here we rewind, this is an accepting state. This string was in an accepting state.
Right.
We rewind.
And we get an accepting state,
Right.
which is not great.
Which is not good.
Yeah.
So in this case, we only had to go back 1 step.
Right.
Does it matter how many steps we had to go back?
I mean, if we go back any number of steps and something is accepted, then we're in trouble.
Exactly.
Right.
Yeah. No, that's the point.
Right.
So
you need the last character.
how can you characterize this in like as like a property of DFAs?
Any final state is only I mean, you need the last character of everything in your language to get to the final state, to a final state.
So let's think about a different machine that is also independently interesting for this problem.
Sure.
It's actually, it almost exposes the issue more. The single state was good for the last problem we were talking about, but it's not ideal. So notice, by the way, that we're talking about a unary language just to vastly simplify things, so I only need a single transition function for each state. So this is literally the language of strings of ones. Or the alphabet is just ones, and so anything in any language is just going to be some subset of the strings of ones. Let's have Q2, which doesn't accept over here, and then we're going to have another state that goes to Q3. I don't know if people can even see this, which does accept, and then this will go to a sync state, which doesn't accept, Q4. And Q4 goes to itself. I mean, you don't even really need to see the ones. The ones
Right.
almost like take up space because it's a unary language. But it is whatever alphabet symbol you're using. Okay, so does this accept a prefix-free regular language?
No, because you can just, the first one will get you there, or that.
So how do we get here? We need three ones, right?
Yeah.
Okay, so 3 1s will get us here. And what gets us here?
1 1.
Right. And so this can be our prefix.
Right.
So does this help us see the property a little better? Check Oh yeah, they can see that well. Good. So, why was I able to get from here to here going backwards?
Oh,
So like basically removing a prefix is like traveling in reverse along the
right. As you
transition
take one,
functions,
you go back.
right?
Yeah.
So, what allowed me to get from here to here then going in the reverse direction of the transition functions?
I could feed the string in backwards to the inverse of the transition function.
Kind of. Yeah, I mean that is actually a good way to put it. But I guess more what I'm searching for is like something simpler.
Uh-huh.
You could get from here to here.
At all. Okay. Right.
Because there's transition functions that take you from here to here, which is all that allows you to go in reverse from here to here.
Right.
So how can we state that as a more general property?
Different final states are mutually accessible.
Well, remember our first example actually, where we just remove everything below here and just
Right.
transition to itself.
Right.
That's not a different final state. It's
Right.
just a final state. So there's
Right.
an even simpler way to state this property. So let's say that I'm actually going to erase this. Let's just let's forget about these two states and just make this the sync state instead.
Okay.
Does that accept? Is that a prefix-free regular language? So let's remove all this.
Oh, so
stuff.
you just have Q1. Yeah.
So this goes to itself. Does Q0, Q1, and Q2 accept a prefix-free regular language? So let's
I
see.
wanna say
One
yes.
gets me to here, right?
Yeah.
If I keep adding ones,
Yeah.
none of those ever accept. So there's no
Right.
longer string that I can remove the prefix of to get back to here.
Right.
So this accepts a prefix-free regular language.
Right.
But what about just stopping at Q2 was so different than going from Q1 to itself or going to this new accepting state, Q3? Because notice when I add these two back in, it does look similar, right? It's got accepting states along the way and then a sync.
Right.
But the problem was that there was an accepting state and then you found this other accepting state along the way.
Right.
And so you were able to remove the prefix and kind of go back to the first
Right.
accepting state.
Right.
Does that make sense?
Yeah.
And in the case where it was just going to itself, you could just go rewind to itself.
Right.
Here, though, notice I get to this accepting state, and then I go somewhere that never gets me where?
Back to another accepting state. Yeah. Right.
So how can we sum this up in one property? I think this actually does end up being easier than the problem we thought we had a second ago.
Sure.
It's different reasoning, but I'll play Jeopardy music in the edit version of this. Okay, just take your time. It doesn't matter.
Yeah.
Stuck or?
I mean, I'm just not sure. I see how once I leave my final state, I can't get back to it. Well.
Yes.
If I leave one final state and I get to another.
Then you can remove the prefix that got you to the next accepting state,
Yeah,
right?
yes,
and
yeah.
go back to the
Yeah,
first one.
yeah.
So that seems to make a DFA that accepts a non-prefix-free regular language, right?
If I get rid of that final state, that makes it a DFA that accepts it.
A prefix-free regular language.
Yeah.
Right.
Yes. That
So
makes sense.
you're so close
I
to
know.
just summing it up in a single nice sentence. So okay. Well, one thing we know, right, is if I have a final state and I give it a transition to itself, can this accept a prefix-free regular language?
It can. But
Really?
It,
What's an example? Let's just do a simple example.
The language that's just one, and it's one.
And
Just a single string, and the string is one.
well, okay, let's draw the DFA for that. I'm going to. Do you mind if I erase this?
Yeah.
Okay.
Actually, let me. Well, I guess you're.
You know what? I'll do it somewhere else. It's fine. Let's right over here. We'll just move this over. Okay. So let's make the machine that accepts just the string 1.
Mm-hmm.
So the start state can't accept, right? Because we don't want to accept the empty string.
Right. Yeah.
This state has to accept because we want to accept the string that's just 1.
Mm-hmm.
So that has to be an accept state. We need to leave this state now, right?
Right.
Because if we don't, then it will accept the string with 2 1s.
Right.
And then this can go to itself.
Right.
Okay, so this is actually the same
Right,
as
so,
part of the. So this does accept a prefix for regular language,
Mm-hmm.
but notice this doesn't satisfy the property I was asking about, which is a accepting state transitioning to itself.
Right.
So, what's the problem if I make any machine that has an accepting state transitioning to itself?
You can always just take the last guy off.
Right.
Right.
Okay, so that's already one rule
Right.
that we can crystallize.
Right.
Accepting states cannot transition to themselves.
Right.
Okay?
Right. Yeah.
Okay, that's a good start. So, and we don't even need to write this because the property that we're going to need is a superset of this. Does that make sense? Like, we won't need to break it down into
Sure,
cases and the
right.
end result, but
Right,
right
right.
now to get to that end result, it's easier to break it down into cases.
Right.
Cannot accepting states cannot transition to themselves. This is probably too small to read. I apologize. Hopefully, I've said it enough times. Cannot transition to themselves. God, I wish these cameras had more zoom. It's really pathetic how bad they are. Okay, so that's one rule.
Mhm.
Let's go back to this one, because this one was a good example. This is the reason I use this example. It's probably the simplest one for it.
Mhm.
So I'm going to have to redraw it, because I crossed things out. Okay. Let's just end all of this and redo it. Okay, so this one does not have any states transitioning themselves, right?
Mm-hmm.
Yet,
It still is
it's still a problem.
because it accepts languages that aren't prefix free.
Right.
Mm-hmm.
And it doesn't have this property, so we obviously haven't gotten
Right.
all the properties that are true of DFAs that accept non-prefix free languages.
Mhm.
Okay. So what was the problem here? Was that you could go from this final state to this final state, right?
Right. Which is the same thing as saying there is a final state that is accessible from another final state, right?
Yeah.
Is this the thing?
Yeah, because this is actually just a subset of it, right?
Right. That's just a.
It would
trivial
be a
example.
final state that is accessible from a final state. You just need to
Right.
leave out the word another final state,
Right.
because going back to yourself is also a problem.
Also a problem. Okay.
So,
Right.
cool, I can just talk about answers, because this homework's turned in. Forgot about that. Oh yeah, answer to 3B as an Easter egg for anybody who watched. What was it? What was the easiest way to put it? It's just oh yeah, the prefix is just whatever took you from one accepting, if you had, for the if and only if statement, if you have an accepting state that you can reach from another, it's just you remove the prefix, you remove the prefix to get back to the previous one.
Right. Yeah.
And the other one, there were no accepting states before the one that you got to from this, and so removing anything just gets you to something else.